All right, number 3. Third installment takes a minute, huh? Assume you use an air conditioner for a total of 137 days, 24 hours per day, at a rate of 7.25 kilowatts per hour. Assume the cost per kilowatt hour is 8.25 cents, and that 1 kilowatt hour is 3,400 BTUs. So obviously we're going to be using BTUs. So number 1, or the first part of the problem, asks us to calculate total number of kilowatts used per year. So we've got 137 days, 24 hours per day. This is going to give us our number of hours, right? Obviously, we don't necessarily need that, but in order to just use correct conversions, so 137 times 24 hours. So that gives us 3,288 hours. And that's pretty much where we need to start with most of these problems, is when we're dealing with calculating for energy use and we're looking at rates, we need to know the time in which it runs. So 3,288 hours. And we are looking for how many kilowatt hours are used per year. Oh, one thing I forgot to put off is that it's this many per year. So that's going to give us hours per year that it's actually used. All right, so we know how long we're using this air conditioner per year. Got that 3,288 hours for the year. And then the rate at which the air conditioner actually uses energy is 7.25 kilowatts per hour. So we're going to use our per hour, and that's going to go on the bottom, and then 7.25 kilowatt hours. That's our energy use for every hour, which sounds super redundant because you got hour and hour, but it's this hour right here that we're actually going to cancel out, and it's going to give us kilowatts used per year, which is what we're actually looking for. So kilowatts per year. So we've got 23,838 kilowatt hours per year. Determine the cost of that air conditioner per year. So we do know we have the cost per kilowatt hour. So now we've got our 23,838 kilowatt hours, and that is all for the year. But we can go ahead and leave that off because we know it's written in here. It's here. We're going to be okay with that. Per kilowatt, we're looking at 0.0825 per kilowatt hour times 0.0825 cents. So that would be $1,966, and we're going to round up to 64 cents. And that's per year. Alrighty. In 7C, we are asked how many kcal are used per year. So remember that you have this list of equivalencies at the top of the page. So you're going to grab something from here. We've got joules and calories. That's the one we're going to need. And obviously we'll need our kcal and all that good stuff. But the kilo is pretty easy to deal with. So right now we're looking at, we've got a total usage per year of 23,838 kilowatt hours. We know that a watt is a joule per second. Oh, no, we can go into this a little bit even better than that. So we can do our kilojoules, right? Or even joules. So I will show you. We've got 3,600,000 joules, which is the same as the 3,600 kilojoules. And that's 1 kilowatt hour. So I can go ahead and go to joules right there. And then I can go to my calories, but I got to get this memorizable conversion, which is the 4.184 joules per calorie. And then we will definitely want to do this 1,000 calories per kcal. And that should get us there. So we got calories, joules, kilowatt. Do they all cancel out? Yes, all but the one that we want. And we are set to do the calculations. And sorry that it's kind of blurry right there. Let me see if I can move that. Nope. Oh boy. Oh well. All right, a little off-screen magic with the calculator, and I'm looking at 20,510,707.5 kcal. And just so you know, to think about that, those three and those three, they also cancel out. Makes it a little bit easier when you're putting it into the calculator. Okay, but I've got 20,510,707.5 boom, boom, boom kcal. Or really at this point is when we might want to give us a 2.05 times 10 to the 1, 2, 3, 4, 5, 6, 7. And this is kcal per year. Let's make it a little simpler for ourselves here. All right, how many BTUs? So we'll still start off with this 23,838 kilowatt hours. And remember that we are given an equivalency here. So 1 kilowatt hour is 3,400 BTU. We don't have to go through, which I did actually, if you see the shadows on my page, I didn't realize that. And then I was like, oh, it gives it to me here, right here. So it's a lot easier calculation. Got my off-screen calculator ready to roll. And there's my calculation at 81,049,200 BTUs per year. All right. And last but not least, number 8. Suppose your electric lights use 400 watts per hour and average 4 hours per day, every day for 1 year. How many kilowatts per year does this represent if 400 watts equals 400 joules per second? Okay, I'm just going to remind myself that this is per year, and I'm going to write this down here as per year so that I don't have to keep that in my calculation all the time. But sometimes I just want to to make it easier on myself. So basically what we're going to start off with is our 400 watts, but instead of 400 watts, we're going to go 400 joules per second. And we're talking about taking that into kilowatt hours. So we know that we want to do the 3,600 seconds. And that's going to give us per hour. Then we're looking at 4 hours per day. And 365 days for every year. For every year. Okay. We are also going to be taking this from joules into kilowatts. We know from our equivalencies that we figured out that $3,600,000 joules is 1 kilowatt hour. Okay. I think that we're there because we're looking for getting this per year, right? So, and I guess I didn't take it all the way out because we're doing the days, but let's get our seconds here, these hours, these days. We're stuck with year. We're out of joules. And now we've got kilowatts per year. All right. We'll do a little off-screen magic. Okay. So we are looking at 5. That's not a 5. We're looking at 584 kilowatt hours per year. Voila. Made it work. Just wanted to remind myself of what was actually in there. All right. So we've got this other problem, which I've done. You can do 2 different ways. One, you can basically say if the lights are saving 60 watts per night, you could set it up to do the whole solve for what it uses, and then you could take the difference. Or you could say like it's saving this joules per second. And we know that gives us that there's 360 seconds per hour. And then that the day that was being talked about here was 4 hours. And that we're looking at 365 days in a year. But then we want to go to kilowatt hours. So for every joule, for every 3,600,000 joules, we have 1 kilowatt hour. And we've got per year in here, right? So now, like, I think we can cancel joules per second. So we get our joules per hour, hours, days, kilowatt hours, joules, cancel, and we'll have our kilowatts saved per hour. Or, like I said, you could do 340, but you'd have to minus that for the savings. So you might as well just do this. What this is the savings, basically the same problem. So it is a total savings of 87.6 kilowatt hours saved in 1 year. If the fluorescent bulb costs $18 but lasts for 10 years, would you consider it a wise investment over incandescent bulbs? I would need to know what my cost is, and if I were saving this many kilowatts per year. So I can assume, let's see, one of these had a cost, right? So if we're assuming similar cost per kilowatt, then we can go ahead and calculate how much that would be. Let's say if it's assuming that it's let's use this, whatever our most recent cost is. What was it? 8.25 cents. Okay. So we'll say we saved 87.6 kilowatt hours, and then the cost of 1 kilowatt hour is 0.0825 cents times. Okay. So that's in a year. So $7.23 a year. If it lasts for 10 years, then you divide that by 10. You're paying 70 cents a year to replace a bulb. Whereas if your incandescents are much cheaper, you'd have to know the investment of the incandescent bulb, because it doesn't tell you how long it lasts, and it doesn't actually give you the price. So that's going to be kind of your make it or break it there. Anyhow, so I would that would be my reasoning, is that it costs $7.23. So after 3 years, it's paid for, but there's no comparison in terms of the cost for incandescent and how long they last. So I'm assuming when it says it lasts for 10 years, it's longer. But that's the catch there. We don't have that info.